Hi everybody, welcome to Unit 4. Congratulations, you've made it. Unit 4, this is lesson number 1. It's called Graphing Inequalities. So today you're going to learn how to define the word inequality and how to graph the solutions of an inequality on a number line. So have your video packet outlines in front of you and let's begin. So we'll have 8 slides to work from today. This is page 1 of 8. So let's begin with the word inequality. So inequality is a mathematical sentence that compares expressions. That's the key word here, compares. Okay? It contains the symbols less than, greater than. This one with the less than with the line underneath it is less than or equal to, or greater than or equal to. So please make sure you write this whole sentence down. To write an inequality, look for the following phrases to determine where to place the inequality symbol. So what does that mean? If I want to use the symbol less than, what keywords tell me less than? Well, you can use the word or phrase is less than, or the phrase is fewer than. Okay, to use the greater than symbol, some phrases that mean greater than would be is greater than, is more than. Okay, and these two symbols are usually fairly new for 7th graders. This one is less than or equal to, and some phrases is, the first one is less than or equal to, and one that's a little more involved is at most, or is no more than. All right, and we're going to practice these in a little bit. So if you're sitting there like, what the heck does this mean and how do I use this? We'll practice these plenty of times. Okay, and finally we have greater than or equal to. And remember, at any point you can pause and write this stuff down. So this symbol means is greater than or equal to. You could also call this symbol is at least. You could also describe this symbol as is no less than. Okay, so take a minute, make sure you have this chart written down. When you're ready, let's move forward. So what you're going to do here is name each phrase. So I gave you a symbol, name the phrase. So why don't you pause for a second, try to name the symbols on your own, and then hit play for the solution. So answer to the first one is equal to. Answer to the second one is not equal to. So the equal sign with the line going through it means not equal. Third one is less than, or anything that you learned in this chart here. The next symbol is less than or equal to. The next one is greater than. And the last one, greater than or equal to. Okay, let's move forward. Okay, we're going to read the statement and circle each number that makes the statement true and then answer the questions. So there's questions underneath this box here. So you are in at least 5 of the photos. So how many photos are you in? Are you in -3? Are you in 0? Are you in 1 of them? Are you in 5 of them? Are you in 6 of them? So you are in at least 5 of the photos. All right, when I see you guys, we'll definitely have some more examples like this to help us with the vocab that we just learned. Okay, so hopefully at this point you have circled 5 and 6. At least means I can be 5, at least 5, or anything bigger, so at least 5. So if you say to your parents or someone at home or a friend, say, I need at least $5, if they give you $10 or $20? Are you going to be upset about that? And hopefully you're saying no. So at least $5 means you need 5 or more. So you're in 5 pictures or possibly more, so 5 and 6. So here are some questions I want you guys to think about. What do you notice about the numbers you circled? Well, they are 5 or greater. Anything less than 5 does not fit this condition. Is the number 5 included? Why or why not? Yes, 5 is included because we want at least 5. That's our minimum. That's the smallest amount that we're in. And finally, write 4 other numbers that make the statement true. Well, the numbers are endless: 7, 8, 9, 10, 11, 30, 50, 100. You guys get the idea? As long as my numbers are at least 5 or larger. Okay, we're going to move on here. So I know the sheet you guys are looking at, all you see are just some random arrows pointing to some numbers. So as I reveal some of these boxes, I would like for you to write all the descriptions that come up. So you are going to have to pause a bit and fill in the blanks. So in this example here on page 4, it says y is greater than -8. So when I look at a number line, which direction represents greater? Going, I mean, if I'm at 0 and I start going to the left, are my numbers getting bigger or smaller? And hopefully you're saying smaller. So -12 is not bigger than -8. So these solutions here, or these numbers here, are not solutions. So I'm going to take a look at 0. If I move to the right of my number line, are my numbers getting bigger or smaller? And hopefully you're saying bigger. So if I test 0, 0 is a number to the right of -8. So y equals 0 could be a solution. So if I put 0 up here in place of y and ask, is 0 larger than -8? Is that a true statement? Is 0 bigger than -8? And the answer is yes. So what we're going to do is, since this inequality sign is just greater, I'm going to put an open circle right over -8. Okay, and here's why. We're going to use an open circle because -8 cannot be in my solution. What does that mean? My values for y have to be larger than -8. If you look at this previous example real quick, I'm going to go back so don't freak out. This says at least 5, so that means 5 can be a solution. But in this example, back to where we were, page 4, y has to be larger than -8. So my question to you is, will the solutions to the left of 8 make my statement true, or will all the numbers to the right of 8 make my statement true? So if you're a little confused, let's think about this. If I go to 2, is 2 bigger than -8? Yes. Let's go to 4. Is 4 greater than -8? Yes. Let's go to -6. Is -6 bigger than -8? Remember, when we compare two numbers, when they're negative, the closer to 0 you are, the bigger you're getting. So yes, -6 is larger than -8. Therefore, we're going to draw a number line. So copy one of these onto your notes. Open circle at -8 because my solution cannot be -8. And then we draw an arrow to the right because anything right of -8 makes this statement true. All right, here we are on page 5 of 8. We have x has to be smaller, less than -1. So my symbol is less than, so I'm going to use what's called an open circle. I'll explain open and closed circle more to you guys tomorrow. Sorry, it's hard to draw with this thing. So open circle. Now let's do a quick test. Is 2 smaller than -1, or is it bigger? Yeah, it's bigger, so we can't use this. So let's go to the other side. Let's go to 5. Is -5 smaller than -1? And the answer is yes. So that means my solution set is anything left of -1. So I'm shading in my number line. And I use this open circle because -1 cannot be in my solution. It has to be things smaller than -1. All right, let's go to the next one. This says z is greater than or equal to 4. So do you notice the or equal to part? So when I go to 4, I'm going to use what's called a filled in circle. All right, so I'm going to use a filled in circle because z could equal 4 or anything larger than 4. So which way are my numbers getting larger, to the right or to the left? And hopefully you're saying to the right my numbers are getting larger. So the closed circle tells me that my solution set here could be 4 or anything bigger. Okay, next example. Here it says S is smaller than or equal to 1.4. So we're going to estimate where 1.4 is. Well, if that's 1.5, 1.4 is right before it. Okay, and less than is 2. If I go to the right, is 2 less than 1.4? And the answer is no, it's bigger. So my solution set is everything below 1.4. Okay, 0 is smaller than 1.4, -1 is smaller. So all of these numbers are smaller than 1.4. So my solution set will continue forever from -1.4, closed circle. 1.4 is a solution, and anything that's smaller than 1.4. All right, and here's our last example. -1/2 is less than t. So here's something fun about this. In equations, it doesn't matter where the variable is, the left side or the right side. In inequalities, the variable has to always end up on the left. So what we're going to do is we're going to flip the t and the -1/2. So since we flipped these two sides, we have to flip the inequality. If you look at the problem up here from left to right, you'll notice that the opening is towards t. So when I flip it, the opening here is still towards t. All I did was turn it around. So t has to be bigger than -1/2. So -1/2 is between 0 and 1, it's right here. Since it's just greater, we're going to use an open circle. It's -1/2. All right, here we go, -1/2. So t must be greater than -1/2. So greater means we go to the right. Okay, so bring all these notes with you tomorrow. If you have any questions, write them down and we'll talk about them tomorrow. All right, thanks guys.